Hi guys, my name is Steven and today I will be demonstrating all the parts for the Multimeter Ohms Kirchoff's Laws lab for the electrical circuits. See, yeah. Okay, so the first things first is you gotta do the first part of the lab, which is the basic resistance measurements. And all that it basically says to do is you set up the meter, and I have mine over here, right? You basically plug in the stuff on the sides. You set the range to 200 ohms. You put at 200, and this first one is basically testing the resistance of the lead itself. So for this one, you want to put the prongs together, or the leads together, and if we do this, if we hold it correctly like that, you can see that it is around 0.2 to 0.3, and it would be 20 to 30 ohms, and that's how much resistance is in this. When you do these itself, when you measure it, sometimes you want to take off the 20 to 30 in the actual measurement of the resistors in the circuit itself. So the next one we're going to be doing is setting it to the 2000 kilo ohms, which is over here. We put it there, and we basically get the leads and we push them onto ourselves, right? So this is basically going to show us the human resistance. You can't see it, but I swear it says between 161 to around maybe 190-ish. So 160,000 to 190,000 ohms. Yes. Cool. That's the first part of the basic resistance measurements. And you would want to write this down in the lab itself. You also want to do this for every resistor to see if that's the actual resistance that the resistor has for each, and make sure you don't have anything bugged. But that's basically what it is. The next part is the next one. Okay, the next one is basic voltage measurement. It says a 9-volt source, and we have ourselves a 9-volt battery, and we have some wires connecting to it. And then on the board itself, we have, if you can see that, it is going to be a 560, yes, a 560 ohm resistor here, and then a 680 ohm resistor here, and it's running in series. So we start up from the top with the power, goes here, here to there, to there, to there, and then it goes with the ground for the battery itself. Okay, so let's see if we can get a better view. We're zoomed in now, and that's a good thing. So first things first, to get our 9-volt battery, and remember, we have our 560 ohm and our 680 ohm, along with our voltmeter. We have the voltage set to 20, and we're gonna just make sure that works. Alrighty. We're gonna first power it up by putting the power into there, and then we're gonna get the ground, and we're gonna put it on the other side. As you can see, there's a sticker here to tell us where to put it for the camera. So let's first test out that there's power going through the circuit in the first place. We're gonna put it to here, see there's voltage, and let's see, will it be 9? It is 9.31. Cool. We're gonna go to the first resistor and see what the first voltage is as it's entering. So there you go. It's going to be 9.32, and at the end of the first resistor, we have ourselves 5.13. The second resistor has the entrance of 5.12, and at the end, it is 0. So let's do this first. We're going to connect it here. We're going to see the beginning, which is going to be 9.3. So let's put 9.3 in and subtract it by 5.13. Minus 5.13, and we have ourselves 4.17, and that's the voltage drop for the first resistor. The next thing we're going to do is we're going to do the same thing again. So we're going to put the black to the ground. We're going to see what this one is, and this is going to be, if you can see that, we have ourselves 5.13. So let's put the 5.13, and let's subtract it by 0, because we know at this point it's going to be 0. So that's going to be 513. And the cool thing is, with the Kirchoff's voltage law, if you were to add these two up, the 513 and the 417, they should equal the power source in the beginning. So we said, what, 9.3-ish? Look at that, 9.3. Can you see that? 9.3. Wow. Kirchoff's voltage law is pretty cool. This is the circuit board right here. This is a perfect circuit board. Let's go on to the next one. It's pretty different, but we'll get there. Okay, so this is basically the same thing as the first one. So it's still voltage measurements, but rather than doing two separate or two different resistors, like the 560 ohm and the 680 ohm. We're doing two resistors of the same resistance, which are both the 4.7 mega ohms. And the one over here is the one and only, as they might say, the 4.7 mega ohms here and the 4.7 mega ohms there. We're doing the same thing as before, and that's putting the voltage in, and we're getting the ground, and we're putting it over here on this side, and we're gonna run it through. We're doing the same thing as we did before. So first, let's just check that the power is going through it. There we go. We have 9.38 volts. Crazy stuff. Now, we want to see what these ones are now. Like before, we assume that this one is also 9.3 whatever volts. So let's just, test it out. There it is, 9.35. We're gonna go for this one over here, also 9.35. Now, we're gonna see the voltage drop from this one to this one after the resistor. So let's just test it out real quick. And we have ourselves 3.82. So we're gonna go to the next resistor, which is the same one. And let's see what that would be. It is 3.79, 3.80. And at the end, let's see what it is. Uh-oh, it's 0. That's how it is. So basically, what we're gonna do is the same thing as before. So let's see this one again. We're getting the 9 volt, and we're gonna subtract it by 3.79 or 3.80, and then we're gonna do 3.7980 minus 0, and we'll add those together, and we're gonna compare it to the power supply voltage. So basically, what we learned here is how to use the multimeter. We also learned how to set up a circuit to check the voltage for each part, and then at the end, utilize Kirchoff's voltage law. Cool stuff. It is currently 5:30 a.m. in the morning on January 27th. I finished a lot like a long time ago, right? But I haven't filmed it yet. And right now I am editing the video. I am around 6 minutes in, not too shabby. But we are about to do the next part. We're doing part 4. Rather than doing series where it's basically like a straight line, so from a power source to like a resistor, and then from the resistor to another resistor to the ground at the end, how it's gonna work is we're gonna get our 9 volt battery, we're gonna put the power plugs in here and then the ground there, and what's gonna happen is the power is gonna go from this part to this one, and it'll flow to these resistors, and then this to the ground and back to the ground itself in the power source. I'm not too sure, but we'll see, and I'll get back to you when we're there. But for now, we're gonna zoom in around here. Okay, I've been trying to figure this out for a while. I'm not sure this is the problem with the voltmeter, but I think I'm gonna leave it here because that's the only way I get values out. I changed it to 20 milliamps. Yes. I have the circuit here. 560 ohms here. 680 here. Yes. So power goes here and goes here to here. You shouldn't measure current in parallel, so it should be series. Okay, let's try this out. So we have the circuit like normal. We're doing the value, and we're gonna do the 560 ohms first. So we're gonna find the current for this. So we put it here and put it here, which should give us a number. So it's 15.6. Now we're gonna move this over to this one and try to find the current. So just flip it around, and then as you can see, you push here. What's it? 12.6. I think I changed it to 200 rather, so I think that should be fine. I think to measure the total current, pretty sure I can move this here, right? I can put this over to here so they both connect, and I can get this and put it here and put this here. You get what, 28.1? Okay, yeah, sure. Let's see that. 28.1. You heard it first. Cool. So let's see if it works. We are going to go to the calculator. We're gonna go 15.7. We're gonna add that to 12.6, and we are going to try to do percent error formula, which is going to be IS, and in this case it's 28.1. We're gonna subtract it by 28.3, and what you get is 0.2. Multiply it by 100, and that's the percent error, which is 20%, which is actually a lot. Yeah, so 20%, that's what we got, and hopefully, if this is correct, the proper way that it is, we got it. Nice. Oh, side note, if I'm being completely honest, I have no idea how currents work, but comparing it to the video itself and other people's videos from the discussion board, this seems like the closest I'll ever get to it. Okay, hi again. So, looking at the rest of the stuff, we done part 1 to part 4 so far, and for part 5 it's saying it's the 1.5 volt. And I have a AA with the wires and stuff. I have the 1 ohm over here. But the thing is, the 91 kilo ohms, I'm looking at the resistors that were given, and I don't seem to have one. I don't know if we're supposed to make one with resistors, but the thing is, even making it with resistors, I can't make 91 kilo ohms. Yeah, it's partly my fault because I didn't realize it at the beginning, but at the same time I was thinking like, oh, maybe I can just put 2 and 2 together, unless that's the way to do it, but I can't do the last one. So yeah, cool.